ඒ වුණානාම වෙලාගෙන
දැක්කෙනන හශයනොයි කවදට හශයනොයි කවදට හශයනොයි හෙසදයයි තවලවරට ලයිබ්‍රගෙන් බලාය
මොකද්ද
කැව
කට්ට ලයිබ්‍රේගේ
හිතන්න මොනාගේ වේද හිතන්න මොනගේ කියලා
පටන් ගන්නද තව කට්ටියනකම් ඉන්නද කිසුම්
තවකට ඒ කියලා හිතනවා තව චුට්ටක් කලාවන්න අයිසේ වේබල හිතුවදරන්නේ සිනෑනේ
මං කිව්වේ පණ්ඩිතයාට
අංගිතමං උඩි පල්ලෙන් වැලේ යට දෙයක්
ඔතන
ප්‍රපෝෂන්
හසිනුත් ඉන්නවනේ ඔකටත් කියන්න පේපර් එක කරන්න කියලා
නෑ වූ මංගේ ගෙදරගෙන ඌයි විහන්ගේ කර මට අද යන්න කම්මැලි ඒක ඒ ස්ට්‍රක්්චක මේකට මට හිතෙන්නේ ඒක අර
ඒ
වෙනසකට
ස්ට්‍රක්චර් එක
තියන්න
නෙවෙයි.
අපිට මේ
ඒකේ දැන් මෙහෙම ඒකේ වැඩියෙන් තියෙන්නේ ඔය ලොගරිතම් ඒව මේව කැලි තියෙනවනේ. ඒ සුට්ට අඩු කරලා මැට්‍රිසස් පාර්ට් එකක් දායි එක.
අන්න හරි හැබැයි අපිට ලොග් කරා නේද ඒක ස්පෙෂල් එකක් විදිහට නේ කරේ අනිවා මැට්‍රිසස් ටික දාගමු මතක
ඒක කියන දේ මයික් ඔන් කරලා කතා කරන්න නැත්නම් එපා. මැසේජ් දාන්න.
ගෑනු නම් එක්කගෙන බලන්න ඊයා චේතක ඊයා
matrices තමයි අන්තිමට කරේ මොකක්ද දැන් ප්‍රශ්නේ? vectors එන්නෙත් ඒකටම තමයි. vectors and matrices තියෙන්නේ. හරියට පටන් ගන්නද?
ඕ පටන් ගවනේ.
Okay. හසෙන් වැඩ කරොත් ඒකක් ගන්න පුළුවන්. මං අතින් අරන් දෙන්නේ නැහැ. Okay. Okay, I'll start with the matrices revision. So first of all, they are going from the beginning, a linear equation. So linear equation is where the power of x is 1. So something like this, x plus y equals 3. This is a linear equation. If you have something like this, x square plus y square equals 4, this is a quadratic equation because the power of x is 2. So just have an idea what a linear equation is. So the power of x is 1. Then so they are saying that for example, now this is a system of linear equations. That means more than, if there are more than one linear equation, it's a system of linear equations. Now there are two results from these equations. First one is consistent, other one is inconsistent. Inconsistent means you have no solution here. Consistent means at least one solution. Now in these two equations, once you solve this one, let's take 1 and 2. So you can't solve these two equations because now if you take 1 plus 2, minus x1 and x1 gets cancelled, x2 and minus x2 get cancelled. Therefore, you can't derive anything. Or else, now let's take the other way, we'll take the negative 2. That means minus x1 plus x2 equals 1. Now, these two equations are the same. The first one, and this, I'll take this one as third. Minus x1 plus x2 equals 3. Here, minus x1 plus x2 equals minus 1. So, it can't happen. So, this is inconsistent. That means no solution in here. So, that's what it means. Okay. Okay, move on to the matrices part. So matrices is just a block of numbers. And there are different types of matrices as well. Now, if you have something like this, 1, 2, 3. This is what you call a square matrix. That means the order is 3 by 3, or order is 2 by 2, or order is 4 by 4. Those are square matrices. That means the block of number makes a square. It's a square matrix. And then there's one called diagonal matrix. That means only the diagonals have the values. Others don't have any value. Now here, only the diagonal has value, so this is called a diagonal matrix. Also, if there are only ones and zeros, that one is called an identity matrix, same as this one. This one, if you have only ones in the matrix, that means it's an identity matrix. But those ones should be in the diagonal, okay? Here, any number can be in the diagonal matrix. Let's take 2, 3, 4. This is a diagonal matrix. This is a identity matrix. And then upper triangular matrix, that means only this part has values. Sorry, not this part. This upper triangle has values. These ones don't have any values. This is called an upper triangle matrix. It's easier to remember those. And same like this, you have a lower triangle matrix as well. And there's a symmetric matrix. You have something like this. Hold on. Now, if you have something like this, that means from the diagonal, if the other sides are mirroring each other, that means here, like this, 4, 5, and 6, this is called a symmetric matrix. Those are the main important ones you need to like remember. And then we'll move on to the operations of matrices. Now, if you have something like this, I'll take A equals 1, 2, 3, 4 matrix, and B equals 3, 4, 5, 6. If you want to perform A plus B, A minus B, likewise, if you want to add or deduct, you have to remember that the order should be the same. Here it's 2 by 2. Here also it's 2 by 2. Order should be same. Now, if we have an order 3 by 2, here also it should be 3 by 2. If only these conditions fulfills, you can perform these operations. So if we take A plus B, how you can do this one is, I'll take this one and this one. Then 3 plus 1, you get 4. Then here, 2 plus 4, you get 6. 3 plus 5, you get 8. And 6 plus 4, you get 10. Same for the subtraction as well. Now, if you take A minus B, so 1 minus 3, you get minus 2. 2 minus 4, you get minus 2. 3 minus 5, you get minus 2. 4 minus 6, you get minus 2. Likewise. Now, if you multiply this a by 2, that means 2a. How you find it is you multiply this matrix by 2. It's easy. 2 times 1, 2, 2 times 2, 4, 2 times 3, 6, 2 times 4, 8. Okay. Then comes the multiplication. We'll multiply a into b. Now there are several things we need to know when multiplying a and b. One thing is here in the order, the last number should be equal to the first number in the other order. So these numbers represent rows and columns. Here also rows and columns. That means rows of one matrix should be equal to the columns of another matrix. If that condition fulfills, the resulting value should take the remaining powers here, remaining values in the order. That means 2 by 2. The answer should be definitely a 2 by 2. Okay, now if we multiply this one, um, now how you multiply this one is taking rows and this column for the first one, for the first place here. 1 into 3 plus 2 into 5. That's the first position. Then the next one, the same row and the next column. They are 1 into 4 and 2 into 6. Here, take the next row and the first column. 3 into 3 and 4 into 5. And here, 3 into 4 add 4 into 6. That's how we multiply. So you have to simplify this and get the answer. Here, 3 plus 10, you get 13. Here, 48, 180. Oh, sorry. Here, 16, 29, 36. Likewise. Now here the resulting value has the order 2 by 2. Okay. All right. Now comes the complex part, Gaussian elimination. Now what this means is that means you have when you are given a system of linear equations. For example, I'll take the same example as the what do you call the lecture material. So it's x x minus 3y plus 5z plus minus 9, 2x minus y minus 3z equals 19, and 3x plus 5 plus y plus 4z equals minus 30. Now in Gaussian elimination, now first of all, we can write this one in augmented matrix method. So what that means is, you basically take all the numbers in this linear equation system and put it into a matrix. So that's what we call augmented matrix. So I'll take the x numbers first. Here 1, 2 and 3. Here -3, -1, +1. And here 5, -3, 4. And then you write the values here. -9, 19 and -30. We can write x, y, z here. Here row 1, row 2 and row 3. This is the augmented matrix. Now there's something called Gaussian elimination. This is a concept. So now this kind of a matrix is harder to solve. You can't straight away get an answer. To make this simple, what they are doing is this small lower triangle here, they make everything 0 in here. For example, if I write this in a Gaussian elimination form, uh, something like this, I'll put values. For these values, I'll put letters. Now Gaussian elimination is like this. So here the small lower triangle is 0. Now how can this help us solving the equations? Now if I take row 3, I can straight away write Fc equals R. Therefore Z equals R over F. We can straight away get an answer. But here we can't, because there are values for x and y as well. And in here, in row 2, we have dy plus ze equals q. Now we already know the value for z, therefore we can find the value for y. That's why we are using Gaussian elimination to for it to be easier to find the unknown terms x, y, z. And there's another concept called reduced row echelon form. Now reduced row echelon form is, now from the previous matrix, you say, now I'll write it like this. Now Gaussian elimination did something like this. They only took the lower triangle and make it 0. In reduced row echelon form, they make the upper triangle 0 as well. So if we convert it into reduced row echelon form, that means it's something like this. Okay, that means only the diagonal has values in the reduced row echelon form. Now this is much easier than Gaussian elimination. Why? We can straight now these are the x, y, z variables. No? So in here, from the third row itself, we can take s z equals w. Therefore, straight away we can write w z equals w of s. In the second row, you don't have two variables, only one variable. So ny equals v, y equals v over n. You can straight away get the answer. Now in here, Gaussian elimination, in the third row there is one variable. In the second row you have two variables. Therefore you have to solve it a bit and then arrive in the next variable. Likewise, in here, reduced row echelon form, you only have one variable per row, so which is easier for you to get the answer. That's the difference between those two. Then there are a few rules for this reduced row echelon form. That means in short term it's called RREF. First one is if we have a row of zeros in this reduced row echelon form, it should be at the bottom. These should be at the bottom. It can't be in the top. That's one rule. And the next one is number of ones should flow like this across the matrix. And the next one is these number ones should be the first terms in the rows and columns. Now here it should be 0 and 0. Like this. If there's a number, now here if you say we have something like this is not a RF. Okay, that's it for the matrix. Matrix is over. No, we have something else also. Um, we have to learn about transpose. Now let's say we take a matrix called A, which is now transpose of A is written like this: A T. Transpose means rows becomes columns, columns become rows. Now here rows become columns. That means 1, 2, 3, 4, 5, 6. This column becomes the row. This column becomes the row. This column becomes the row. Sorry, this row becomes the column. You can take it the other way as well. This column becomes the row, and this column becomes the row here. And then inverse of a matrix. I'll take it like this: A, B, C, D. Now this is the matrix A. If you want to find the inverse, that means A inverse, first of all you have to find the determinant. This determinant means these two, that means this one and this one, the diagonals. You should multiply and deduce. AD minus BC. This is the determinant. So A inverse means 1 over det into a certain form. So here you can write 1 over AD minus BC, and then you have to interchange this diagonal. Interchange means here A goes to this place and D goes to here. And the next, the other diagonal, we have to negative it like this. Now this is the inverse. First of all, find the determinant. That means multiply the diagonals and subtract. And then take the first diagonal, interchange the place. Take the second diagonal, don't interchange the place, just negative the values. That's it. And then we'll move on to vectors. Okay, vectors. Now there are two quantities called vector and scalar. Scalar means have a magnitude but no direction. In vector, you have a magnitude as well as a direction. For example, something like this. I'll take this one as A. This is a vector, A vector. It has a value A, and the magnitude is the length of this vector. Now, if we are given something like this, we have here A and here B. You are asked to draw A minus B. So how can you draw it? Minus B means the direction reversed. If this is B, minus B should be something like this for this side. We can copy the same because same length here. Okay, now it's A here minus B, here also minus B. So A minus B. So this is the A minus B vector. We just have a rough idea how to draw these. And then we have vector addition and vector subtraction. Now let's say we have vector called A, which is 2, 3. So this is the x coordinate and y coordinate here. And I'll take B as minus 8, 4. So A plus B means addition of x coordinates and addition of y coordinates. 2 minus 8, 3 plus 4. You have minus 6 and 7. Subtraction also goes like this. If we have A into B, then what you can do is you can multiply the x coordinates and add the y coordinate, the product of y coordinates. For example, 2 into minus 8, what you have is minus 16 plus 3 into 4, 12 minus. You can't multiply the x coordinate with y coordinate, okay? And here also y coordinate with x coordinate. You can't multiply. You only can multiply the x coordinate itself and the y coordinate itself. And that's it for the revision part. Any questions? Yeah, for the vectors, only like the basic parts of A level are there. Yeah, it's a small lesson actually. I just like speed up everything. It's easier, okay? So we'll discuss the paper I have given. I hope it's okay. Yes, I taught inverse of matrices. Who's this? If you can't remember, inverse of matrices is something like this. 1, 2, 3, 4. If you take A here, A inverse means first of all find the determinant, multiplying the diagonals, okay? 1 into 4, 4, minus 3 into 2, 6. And then the first diagonal interchange for 1 and the second diagonal negative the values. This is the inverse. Okay, no? Okay, I'll discuss the paper. Those are some hard questions I found on the tutorial and from the CS papers as well. So the first question is given below are two 3 by 3 matrices. Perform the following operations: 3a minus 2b, 2a plus b, ab and a transpose. Okay. So here a equals 241,053,678. I'm also doing the answers real time. So if I make a mistake, just tell me. Okay. B equals 132,405 and 768. 3a minus 2b. I'll straight away write 3a. So everything multiplied by 3. You get 6, 0, 18, 12, 15, 21, 3, 9, 24. Minus, here everything multiplied by 2. You get 2, 6, 4, 8, 0, 10, 14, 12, 16. Now when you are reducing, first row first column minus first row first column. Okay. 6 minus 2 4, 12 minus 6 6, 3 minus 4 minus 1, 0 minus 8 minus 8, 15 minus 0 15, 9 minus 10 minus 1, 18 minus 14 you get 4, 21 minus 12 you get 9, 24 minus 16 you get 8. Just check whether this is the answer. Did anyone of you do the paper? At least write some questions. Okay, great. Kavisha, is this the answer you get? If not, if I'm making mistakes, just tell me, okay? Then the next one, 2a plus b. So 2a plus b. Here you everything multiplied by 2, you get 4, 8, 2, 0, 10, 6, 12, 14, 16, plus 1, 3, 2, 4, 0, 5, 7, 6, 8. So when you add those two, you get 5, 11, 4, 4, 10, 11, 19, 20, 24. Okay. And then I'll do AB. AB, you can write something like this. 2 into 1, 2. 4 into 4, 16. 1 into 7, 7. Then again 0 into 1, 0. 5 into 4, 20. 3 into 7, 21. 6 into 1, 6. 7 into 4, 28. 8 into 7, 56. That's the first column. Then the next one, 2 into 3, 6. 4 into 0, 0. 1 into 6, 6. 0 into 3, 0. 5 into 0, 0. 3 into 6, 18. 6 into 3, 18. 7 into 0, 0. 8 into 6, 48. Okay. And then 2 into 2, 4. 4 into 5, 20. 1 into 8, 8. Here 0 into 2, 0. 5 into 5, 25. 3 into 8. 6 into 2, 12. 7 into 5, 35. 8 into 8, 64. Okay, so once you simplify this, 16 plus 2, 18. 18 plus 7, 25. 20 plus 21, 41. 6, 6, 12. 8, 20. 5, 2, 7, 8, 9. Yes. And then 6 plus 6, 12, 18, 66, 32, 49, 111. Just check whether this is the answer you get. I think I did a mistake. For 28. Is this the answer you get? Okay. Okay, great. Next one. Transpose of A. So A transpose, rows become columns. That means 2, 4, 1, 0, 5, 3, 6, 7, 8. That's the transpose. So we haven't taught how to do the 3 by 3 inverse of a matrix. We have only taught the 2 by 2 inverse. So we'll stick into that because 3 by 3 is a bit more complex. 3 by 3 of the matrix. Okay. Sorry, 2 by 2. So the matrix is minus 1, 3, 4, and minus 2. So inverse is, I'll take this one as A. A inverse is 1 over, multiply these two, you get 2, minus, multiply these two, get 12. And then uh, take the first diagonal, interchange, minus 2, minus 1, and the second diagonal, negative the values. So minus 3, minus 4. So A inverse is 1 over minus 10, minus 2, minus 3, minus 4, minus 1. If you take all the minuses out and multiply the minus 1 outside, you get 1 over 10 times 2, 3, 4, 1. You get an answer like that. Okay, I'll move on to the next one. Solve the following set of linear equations using an augmented matrix and the Gaussian elimination. Okay. So I write the augmented matrix itself. 2, 3, minus 1, 4, minus 1, 5. And then minus 2, plus 1, 3. Here, 1, 2, 3. Okay. So Gaussian elimination means you have to make this lower triangle 0. So what can you do? First I'll take the R2. That means the second row. Second row, and so whenever you're making a change, you can you're putting a star mark or a cross like this. I'm putting a star mark if you want. You can put a cross like this. Okay. So that means you are making a change to R2. So the new R2 I can take 2 times R1 minus R2. So how you can solve this one is 2 times R1. I'll take the row 1 and multiply it by 2. That means 4, 6 and minus 2 and 2. And then R2 is 4 minus 1, 5, 2. We are subtracting it. So 4 minus 4, 0. 6 minus minus 1, 7. Minus 2 minus 5, minus 7. 2 minus 2, 0. Therefore, the new, so I'll make the changes here itself because it's a whiteboard. If you are writing on paper, you have to write everything. Okay. Again. 0, 7, minus 7, 0. Okay. So I made the first 0 here. Then I have to make this 0 and this one also 0. Then I'll take R3. What I can do is R1 plus R3. So I'll take R1, 2, 3, minus 1, 1. And then R3, minus 2, 1, 3, 3. You are adding those two. 2 minus 2, 0. 3 minus 1, 3 plus 1, 4. Minus 1 plus 3, you get 2. 3 plus 1, 4. So the R3, the modified version is 0, 4, 2, and here 4. Okay. Then I have to make this for 0. What I can do is, now you are making another change to this modified R3. Therefore, you can add another cross like this. So what you can do is, I'll take the R3 cross and multiply it by 3 by 4 minus R1. If I multiply this by 3 by 4, you get 3 here. 3 minus 3, you can get a 0. Okay. Then 0, 3, 3 over 2, 3. R1, you get 2, 3 minus 1. Oh no, you can't do that. No, we can't do this. Hmm, we can take R2. I can do 704 minus R, minus R2. So R3 cross 704 0 7 702 7 minus 0 7 minus 7 0. Subtract, we get 0 0 and 702 minus 7. We get minus 702 and 7. Therefore, R3 double cross is 0 minus 702 7. Is this the answer you get? Did I do a mistake? R3. Seven over two minus minus 7. Oh yeah, 7 over 2 minus minus 7 means plus 7. So 14. Yeah, it's 21 over 2. Yeah. Other than that, is it okay? Yeah, I need the answers. Is it okay? Great. Now you can solve the equations. So I'll take this one z 21 over 2 z equals 7. So here 3 you get z equals 2 over 3. And then 7y minus 7 z equals 0. That means y equals z, y equals 2 over 3. And then 2x plus 3y minus c equals 1. 2x plus 3y minus y equals 1. 2x plus 2y equals 1. X plus y equals half. X equals half minus 2 over 3. X equals 6 minus 1 over 6. Are these the answers you get? Okay. Okay, moving on to the next one. Perform the following operations on the given two vectors. So A is given 3 minus 2 5 and B is given 1 4 minus 3. We have to do A plus B. Easy. 3 plus 1 4 minus 2 plus 4 2 5 minus 3 2. 3A means everything multiplied by 3 here. Give me a second. Here 3 into 3 9 minus 2 into 3 minus 6 5 into 3 50. And then AB 3 into 1 3 plus minus 2 into 4 minus 8 plus 5 into minus 3 you get 50. Here you have minus 5 minus 15 you get minus 20. Okay, and then solve the following vector and determine the values of x, y, z. These values are okay now? We got the answers. Okay, I'll move on to the next one. Two x minus 5 3y plus 2 4z over 3 minus 1 equals 7 10 5. We have to just equate the x coordinates with x coordinates here, y coordinates with y coordinates. So 2x minus 5 equals 7, 2x equals 12, x equals 6. And here 3y plus 2 equals 10, 3y equals 8, y equals 8 over 3. 4z over 3 minus 1 equals 5. 4z over 3 equals 6. Z equals 9 over 2. Okay, now Okay. Next one, state the relevant divisibility rule and show that uh, that value is divisible by 6, 7 and 11. Okay. Divisibility rule of 6. So there are two things you need to check. First one is the last digit should be ending with 0, 2, 4, 6 or 8. Next one is the sum of the integers, sum of the digits should be divisible by 3. Those are the conditions you need. So the number is 2587956. So this digit is ending at 6. Okay, and then we have to add those values. 2 plus 5 7, 7 plus 8 15, 15 plus 7 22, 22 plus 9 31, 31 plus 5 36, 36 plus 6 you get 42. 42 is divisible by 3. You get 40. Therefore, this value is divisible by 3. Okay. Divisibility rule of 7. So what you can do is you take the number 180,495. So divisibility rule of 7. How you find is this: take this last digit and multiply it by 2. That means 5 times 2 10, and that should be deducted by these two numbers. You get 9 and 3. Okay. Again, take the last number, multiply it by 2, subtract. Mm, 5, 8, multiplied by 2. So you get a 0 here. That means this is divisible by 7. Is it okay? Did you get the concept? You take the last digit, multiply it by 2, and subtract it from the, not the taken number, before that, the number before. And you proceed like this. Ultimately, the remainder should be 0. 0 or any number divisible by 7. Okay. Divisibility rule of 11. Okay, so the number is 3901,436. What you do is you take the adjacent numbers and add them. Here 3 plus 0 plus 4 plus 6, you get 13, minus 9 plus 1, 10 plus 13 equals 0. If this is 0, or the number is divisible by 11, this is divisible by, the whole number is divisible by 11. So all the three numbers are divisible by, first one is divisible by 6, second is divisible by 7, and third is divisible by 11. Okay, now I will go on to the next one, fifth one. Let's see equals minus 2 minus or 0 1 2, d equals 1 2 3 4 5. Define a relation R between set C and D as follows: a square plus 1 equals b, where a is an element of set C and b is an element of set D. Identify the ordered pairs that form the relation R. Okay. Now here C is minus 2 minus 1 0 1 2. D is 1 2 3 4 5. It says that a square plus 1 should be b. Now let's take minus 2. Minus 2 square means 4. 4 plus 1, 5. Then you can get minus 2 comma 5. One ordered pair. Minus 1 squared means 1. 1 plus 1, 2. That means minus 1 and 2. If I take 0, 0 square means 0. 0 plus 1 means 1. So 0 and 1. Next one is 1 square means 1. 1 plus 1, 2. Here 2 square means 4. 4 plus 1, 5. These are the ordered pairs. Write the relation R in set notation. That means set builder form. You can write it like this. R how should we write this? Two variables a comma b, where a is an element of C and b is an element of D, and a square plus 1 equals b. Yeah, I think it's correct. And then determine if R is a function, justify your answer. Determine if R is a function. Okay. Now I'll take here minus 2, minus 1, 0, 1, 2. This is set C. Set D 1, 2, 3, 4, and 5. Here minus 2 maps to 5. 2 also maps to 5. Minus 1 maps to 2. Plus 1 maps to 2. 0 maps to 1. Now this is a many to one relationship. If it's a many to one relationship, then it considers as a function. Therefore, this is a function. Okay, now? If you have any questions, ask me. You have to write this is a many to one relationship, therefore this is a function. Yeah, it's okay if you write it like this. Okay, next question. Uh, okay, logic tables. Show that the compound proposition P goes to Q and Q goes to R goes to P goes to R is a tautology. I forgot to tell you in the matrices, A B is not the same as BA. Okay, that's an important thing you have to remember. Okay, P goes to Q and Q goes to R, and this whole thing goes to P goes to R. And now tautology means all the output should be true. Contradiction means all the output should be false. If I solve this one, P Q R, P goes to Q, Q goes to R. I'll take this one as A, this one as B, A and B. Then P goes to R. I'll take this one as C, and this whole thing as B. B goes to C. Okay. So the truth values are then true, true, false, 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 true, false, false. Then P goes to Q. I'll give you guys a small trick to remember this one. Now, if P goes to Q, how you remember the results is, if you draw a truth table for this P goes to Q, for Q it's true, false, true, false. No? All the falses, no matter the second output, is true. Okay, and here only true goes to true is true. The only variable is true goes to false. That should be definitely false. If the in the first set all the false, if you have false in the first set, then everything becomes true, no matter true or false in the second one. In the truth values, true goes to true is the only truth. True goes to false is definitely false. That's how I remember it. So P goes to, so the false values are definitely true. And here true goes to true, true. And here false. And Q goes to R. True, false, true, 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 false, and true, true. Okay, A and B. So here true, false, 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 true, false, true, and true. Then P goes to R. Last four values are true. P goes to R. True goes to true, true. True goes to false, false. True goes to true, true. And true goes to false, false. and um, and then these two columns, true goes to true, true. These are true, and true goes to true, true, true. Now see here, the last result, everything is true. Then you can write therefore this logical expression is a tautology. Okay, no? Next part. Determine whether the following system specifications are consistent. Okay. If I take whenever the system software is being upgraded, so system software is being upgraded, I'll take this one as A, and then user cannot access the files. I'll take access the files as B, and then save new files C. Okay, the first statement. Whenever the system software is being upgraded, users cannot access the file system. That means A goes to B. If the user can access the file system, they can save the new files. If user cannot save new files, then the system software is not being upgraded. Something like this. Okay. This one can be written the same as like this. A goes to C. This one. So if you take these statements, if I take assume A equals true, if A equals true, for this whole statement to be true, negative B should be negate B should be true. Negate B true means B should be false. Okay, and here if A is true, C should be true. Okay, now test these values on the second statement. B goes to C. That means false goes to true. False goes to true is true. Therefore, these set of values are correct. Now, this is assuming A is true. What if A is false? If A is false, negate B should be either true or false. So there are two values for negate B. B equals true and B equals false. If B equals true, C should definitely be yes. I'll take the third one. If A is false, the same thing. Okay. So if B is true, C should definitely be true. Here, if B is false, C have two values, C true and C false. Okay. I'll take the first scenario, that means this one. So we are testing the theory on the third statement. A goes to C. Now, if A is false, C is true. False goes to true is true. Therefore, this one is correct. And the next one is this whole thing. If A is false, C goes to true. Then the whole statement is true. This one is also correct. If A is false and C is false, that's also correct. Therefore, you can say that all the conditions are true. That means the system is consistent. Passing to the Kaulak Mane? Okay. Next question. Translate each of those statements into logical expressions using predicates, quantifiers, and logical connectives. Let the domain consist of all the students at UCSC. Okay, this is CS past paper. So I'll take uh, being perfect as P and being friend as Q. As F. I'll take F. Okay. So no one is perfect. How will you write that one? No one is perfect. That means I'll take this one as X. So X is a student. So PX means a student being perfect. FX means student being friend. Student at UCSC. Okay. So no one is perfect. How can you write? No one. That means for everyone. This applies for everyone. For all X, PX is negate. PX negate. Okay. And then not everyone is perfect. Not everyone is perfect. That means everyone is perfect. That statement negate. So you can write like this. Uh, everyone is a friend, and you can negate this. Okay, now here what it says is everyone is a friend. Everyone is perfect. Everyone is perfect, and the statement is negated. Therefore, not everyone is. Next one. Um, all your friends are perfect. That means it applies for everyone. All. For all legs. if it's your friend, they are perfect. That means fx goes to px. Everyone, for everyone, okay? Everyone is your all your friends are perfect. If they are your friend, they are perfect. Fourth one, everyone is your friend and is perfect. So for everyone, they are your friend and they are perfect. Like this. Okay. And the next one, fifth one, at least one of your friends is perfect. At least one of your friend is perfect. So how we can write this one is at least one. That means some of them. Okay. Some of the friends, at least one of your friends is perfect. So they should be a friend and they should be perfect. So fx and px. Here, at least some. That means not everyone, but some of them. That's why the existentially quantified statement. Effect, they should be a friend and they should be perfect. That's it. Okay. Eighth one. Test the validity of the following argument. This is okay now? Any questions? Last implies නෙමෙයිද? Last again. At least one of your friends is perfect. At least one of your friends is perfect. Uh, Mechanism. Yeah, that's correct. But how do I explain this one? So, someone saying that it hints at the existence of friends who are perfect. Yes, they should be a friend and they should be perfect. At least one of your friends is perfect. So here the statement is with certainty. That means at least one of your friends is perfect. It's, so the statement is like certain. It's not like if they are your friend, they are perfect. That's not it. Uh, so it's how do I explain it? Oh, at least one of your friends is perfect. They should be my friend and they are perfect. They should be perfect. Here, friend being a friend and being perfect should go together. At least one of your friends is perfect. There should be an and here. In the third one, they say all your friends are perfect. All your friends are perfect. If they are not your friend, they are not perfect. Is it? No, no. That's not what they are implying. So here it goes to implication. Imply. Imply. අවුලක් නැද්ද පසුබිම එක? තේරුණාද? Okay, okay. Eighth one. Test the validity of the following argument. No professors are ignorant. All ignorant people are vain. Therefore, no professors are vain. Funny coming from the UCSC. Okay. I'll take the statements. I'll take being a professor as P X, and then ignorant as IX, and then vain as VX. Okay. First one is no professors are ignorant. That means all professors are not ignorant. So for all X, if they are professor, they are not ignorant. Then the next one is all ignorant people are vain. All ignorant people are vain. So for all X, if they are ignorant people, they are in vain. Okay. Then the next one, therefore no professors are vain. For all X, no professors are vain. That means if they are a professor, they are not vain. Okay. These are the statements. What are they asking? Test the validity of the following argument. So how do you verify this one? We'll take px equals true. If px equals true, negate of ix should be true. If negate of ix is true, ix should be false. Okay, and here px is true, that means negate of vx should be true. Negate of vx should be true means vx should be false. Now let's test this case on the second one. Ix goes to vx, that means false goes to false. That is true. Therefore, this case is correct. Let's take px equals px is false. If px is false, negate of ix can be either true or false. Ix is true, ix is false. If ix is true, I'll take the second statement. If ix is true, vx should definitely be true. Now test this theory on the third one. px goes to negate of vx. That means false goes to false. That is true. Okay. And this one, ix goes to vx. So false goes to, so vx can be two values. Vx can be true and vx can be false. Okay, test that theory on third statement. px goes to negate of vx. So px is false, negate of vx is according here false. So false goes to false. True. Then again, false goes to true is true. Therefore, under these cases, these three statements are valid. Okay, no? Any question? Then I move to the next one. Determine the truth value of each of these statements in predicate logic if the domain for all variables consists of all integers. Okay, so the domain is all integers. Okay, and they are saying for all n and sum of m, n plus m equals 0. For all the values of n and some values of m, this statement is 0. So how do you go on that? We'll take some values. -1. For this to be true, what are the values you should take? Here 1, here 2, 0, -1, -2. Here, all the values of n can be chosen, but only the sum of those m should be used for this statement to become 0. Right? If it's -1, definitely it should be 1 from m for this statement to be 0. Therefore, this is true. The statement is true. For all n can be any number. If n is any number, n should be a particular value. The negative of the n value for it to be 0. Now, if you write it like this, n equals -m now. For all values of n, m should be the negative value of these, not the positive values. You can't take all the values for m. So I think that one is true. Okay, now next one. For sum of n and all m, n less than m squared. Sum of m, n and all m, n should be less than m squared. You can take any number for m. So that means I'll take 1, minus 1, 2, 0. So squared means 1, 1, 4 and 0. For this to be greater, these n values should be limited. The n value should be less than 1. So not all of the n can be used here. Some of the n can be used. Therefore, the second statement is true. Okay. I hope you guys got that one. If you have questions, ask me, okay? And then the third one, for sum of n and sum of m, n square plus m square equals 7. For sum of n and sum of m, n square plus m square equals 7. Which two squares give 7? We take 1, then m square should be 6. No? So m should be root 6, which is not an integer. Okay. If we take 2, 2 times 2, 4, then this should be 3, root 3 square, no, which is not an integer. So this statement is false. Okay. The third statement is false. Fourth one, for sum of n and sum of m, n plus m equals 4 and n minus m equals 1. Okay. N plus m equals 4 and n minus m equals 1. If we add those two, you get 2n equals 5. N equals 5 over 2. This is not an integer. Okay. And then if we subtract these two, you get 2m equals 3. M equals 3 over 2, which is also not an integer. Therefore, the fourth one is false. Fifth one, for all n and sum of m, n squared should be less than m. For all n and sum of m, n squared should be less than m. If we take any number for n, I'll take minus 2, minus 1, 0, 2. So n squared means 4, 1, 0. I'll take 3 here, 9. Should be less than. If we take all the values, all values for n, so there are limited number of values that can be taken for m. N should be greater than 4, not less than 4. So therefore, you can't take all the values of m. Therefore, this one is true. For sum of m, no. N you can take any number. M only limited. Therefore, the fifth one is true. Okay, ninth one. Now I did one what do you call one matrix like this. Try to solve this one. I'll give 5 minutes. Meantime, if you have questions, ask me. Okay, I'll do the next one. Given below is a linear system of four variables. P, Q, R, S. Convert the above linear system into an augmented matrix. Okay, P, Q, R, S. You have 2, 4, minus 2, and 1. Here you get 3. Next one, 1, 2, 1, 0. And the answer is 0. Then you get 3, 6, minus 1, 2. Then you get 4. This is the augmented matrix. Okay. So how you solve this one? Reduce the above matrix into a reduced row echelon form. How can you reduce this into a row echelon form? RF. What we can do is we can make this whole thing 0. Now, mind you that this is not a square matrix. So there are 4 columns and 3 rows. Therefore, we can now if it like this. Now this is a square matrix, no? If this is a square matrix, then in the row echelon form, only this diagonal could have values. These should be 0. But here we can do it. There is no diagonal. There is a diagonal, but not a what do you call symmetric one like this. Then what we can do is we can make this whole row 0 and you can make this value and this value 1. If we are making these values 1, these two should be 0, this should be 0. Can you understand that? If you don't understand, just tell me, okay? You can't understand. No as in you can't understand, or no as in you don't have a problem. What is yes mean? Can't understand. Okay. Now, I imagine. Okay, why did I? 2, 4 minus 2, 1, 3, and 1, 2, 4, 3, 6 minus 4. And then vehicle എല്ലാവരും പാടാങ്കുറങ്ങൾ തരുന്നു 2 and 4. Okay. And now, if this was a square matrix, okay. For example, the previous one, 4, 5, 6, 7, 8. I'll take this one as ABC. Now, when you reduce this into a row echelon form, it should be something like this. These should be this, only this row could have values. Okay. Others should be 0. That means something in the form like this. Can you get this one? Can you understand this part? Huh? Okay, you can understand this part. Possible make a theorem, make what is a theorem? Okay. Now we need to convert this whole matrix into something like this. But we can't. There's no defined diagonal here. No? There's no defined diagonal. No? So what can we do? So how you can do this one is how should I explain this to you? Uh, now For example, write this one in the RRF form, reduced row echelon form. It could be something like this. There should be 1 in the beginning. This value 1 is called leading one, the first one here. The others you can get zeros. And then there's another rule of RF. This 1 should go down diagonally across the matrix. Okay, that means if there's 1 here, the next one should be where? Here? No. If the 1 goes like this, it's not across the matrix. Only sum of it. What about this row? So it goes like this. 2 and 4. Here, this 4. That should be 1. Okay. If there is 1, there's another rule which says anything before these ones should be 0. There can't be any value before these. Therefore, this one is 0 and this value should be 0. Okay. What else? What are the other rules of RF? So these should be 0. Okay. Other than that, everything else can be taken for a value, I guess. But now in row echelon form, both upper triangle and lower triangle should be 0. That means this one and this one. Therefore, these should also be 0. Yeah, that's it. Other than that, you can take any value. But then again, you can't write 1 here. Why? Because you have to maintain the diagonal across the matrix. What are you saying? So one is saying first row, second column. First row, second column. Don't need to be 0. Yeah, it's not. It doesn't need to be 0. Anything before 1. So here this one is a leading one. There's nothing before this one. Now in this one, before 1, that means in the column above, there shouldn't be a value. And in the row here, there shouldn't be a value in front of the 1. Got it, Rima? Okay, great. But then again, you can't have a 1 here. Why? Because you have to maintain the diagonal across the matrix. So these should be 0 too. Here you can have any value. It's fine. But other than that, this should be the form. For this one, you have to know all the rules of RFO. One is there should be a leading one, and the matrix, these ones should, the diagonals of one should go from top left corner to bottom right corner. Yeah, bottom right corner. And then if you have any column or any rows of zero, it should be at the very end. And if there are, if there is one, there shouldn't be any value before that one. That means row wise and column wise. Okay, no? Now okay. Pasindu, who was the other one? Tarush. Now you got the concept. Are you okay? Okay. All right, great. So if you got it, then it's fine. Okay, now let's solve this one. Okay, so you have to make everything zero, which is a long process. And in CS paper, they have only given 7 marks for this question. How do you do this one? So what should be what should be the zeros? This one. These two should be 1. Okay. And these also should be 0. The round ones are 1 should be 0. The squared one should be 1. Then you have to convert everything, do calculations. I'm not going to do it, okay? That's too much. If you have a question regarding how to get the answer, I'll do it later and put the answer on the group if you want. Is it okay, or do I have to do it? Did anyone found the answer? R. Yeah? Anyone found the answer? R? No one. Okay. Okay, I'll move on to the next one. Check whether the function y equals 4x minus 5 is inversible. If so, find the inverse of the function. So what is the condition for it to be inverse? Someone's put an answer. Yes, 1 to 1 and on to. That means all the values should map to one value. That means let's say A, B, C, D, and 1 to 1 and on to. On to means the domain equals codomain equals range. No. Yeah, codomain equals range. So here codomain and range are equal. When you take this equation y equals 4x minus 5, you can, I'll tell you the easiest way to find this condition for function. You do a graph. That's the easiest method. So 4x minus 5, how do you do it? When x is 0, y is minus 5. When y is 0, x is 5 over 4, something like this. So graph goes like this. Now here, for all the values of x, there is a y value, no? For all values of x, there is a y value. Therefore, this is 1 to 1. 1 to means codomain and range should be equal. So codomain and range should be equal. It is equal, no? Range is from here to here. Codomain is also like that. Therefore, this function is inversible. So what's the inverse? Here you subject x. So y plus 5 over 4 equals x. Now, don't ask me why. We switch x and y places. Okay. So x plus 5 over 4. Here y inverse. That's the inverse. Okay. This is easy now. Next one. It is given that fx equals 2x plus 3, gx equals 5x minus 1. Calculate g or f inverse. Okay. First of all, we have to find whether f is inverse. So 2x plus 3, obviously it's inverse. Y 2x plus 3, no? When x equals 0, y equals 3. When y is... So graph goes like this. If graph goes like that, all the x values have a y value and the domain, the codomain and range is equal. Therefore, fx is inversible. That point you have to write first. After that only you have to find the inverse. So f inverse is x minus 3 over 2. Now you have to find g of f inverse. G is 5x minus 1. For x, you substitute this value, x minus 3 over 2 minus 1. Minus 15 minus 2 over 5x minus 17. This is the value. Okay, now? Next one. Each user on an online platform must create a password that is exactly 8 characters long. Each character in the password can be an uppercase letter, a lowercase letter, a digit, or one of the special characters. Those 3. Each password must contain at least one digit and at least one special character. How many possible passwords are there? Now this is easy. The possible passwords are all the passwords from all the passwords you deduct passwords without any digit. and also deduct passwords without any special character. If you do this one, you can get the possible passwords, right? Is there another one? Or there should be another one. Passwords without any digit and any character. Both of them. Why? Because now they are saying each password must contain at least one digit. There should be at least one digit or one character and at least one special character. No, not this one. Now, there are passwords without any digits. You can deduct those one. And there are passwords without any special characters. You can also deduct those. Then, in these passwords without any digits, they may have passwords without any digits and characters. As in, like, you don't have any digits, but you have some characters there. Okay, that one you can't take, right? Here, passwords without any special characters. That means you might have digits, but you don't have any characters. Those ones also you can't take. And there are passwords without any digit or character. Those ones also you can't take. Easy. Is the concept correct? Anyone tell me? Because I'm not confident in this lesson. I might make some mistakes. Is the concept correct? Okay. Let's see. So all the possible passwords are what? So how many possible passwords? So there are uppercase, lowercase, digits, and 3 special characters. Then altogether you have 6 plus 6 and 65 possibilities. That means 65 to the power 8 for all the passwords. Okay, 65 to the power 8 minus passwords without any digits. If they don't have any digits, that means from here 10 should be deducted. There are no digits now. So 55 possibilities are there. Therefore 55 to the power 8 because there are 8 character length. And then passwords without any special characters. That means If you have 65, if there are no special characters, then you have 62. 62 to the power 8. Passwords without any digit and any character. Shouldn't it this be plus? Because now imagine 4, 5, 6, 7. There are 8 character length. Okay, passwords without any digits. That means there are no numbers, but there can be special characters. As well as there can be there can't be any numbers, but there can't be any characters as well. So this portion, part of this one, is inside here already, isn't it? Passwords without any digits. That means there are no numbers, but there can be characters or there won't be any characters. Both the possibilities are there. Okay? And then here also, passwords without any special characters. That means there can't be any characters, but there can be numbers or there can't be any numbers. Two possibilities are there. Right? This is like a set. Passwords without any digits. That means this one. No digits. Here, no characters. Now, if we add those two together, this circle and this circle, this small part is repeating twice. Isn't it? If we are adding these two, we have to deduct one part of this. Can you get that idea? If I number these, now no digits means 1 and 2. Okay? And no special characters means 2 and 3. Now here, 2 is repeated. There should only be 1, 2 and 3. But 2 is repeated. For that, we have to deduct 2 from here. 1, 2, 2, 3. Therefore, this should be added here. I hope you got it. Yes, the union formula. Therefore, here plus passwords without any special character or digit. That would be 65 minus 30. You get 52 to the power 8. This is the answer. Okay, now next one. What is the minimum number of books required in a library to ensure that at least 4 books belong to the same genre if there are 6 different genres available? Fiction, non-fiction, mystery, fantasy, biography, and science fiction. Okay, let's do that now. There are 6 different genres: fiction, non-fiction, mystery, fantasy, biography, and science fiction. Okay, they are saying what is the minimum number of books required in a library to ensure that at least 4 books belong to the same genre. At least 4 books. That means each of these genres have 3 books. Definitely. There's no question about it. Okay. At least 4 books means you can add 1 for here. Therefore, the minimum number of books is 1, 2, 3, 4, 5, 6. 3 times 6, 18 plus 1, 19. I hope you got that done. Okay. The concept used here is pigeonhole principle. There are 6 types of books. That means 6 pigeons, but 4 pigeonholes. Is it? Or the other way around? Or else you can just use common sense like this. So how I got this one is they say at least 4 should be there, belong to the same category. Therefore, there should be definitely 3 books in each category like this. And you can put 1 here to make sure that at least one of the genre have 4 books, which comes to the answer 19. Okay, next question. A club has 25 members and they need to form a committee of 5 members to organize an event. Okay, there are 25 members. From them, 5 members are needed. How many different ways can the committee be selected if all the members have the same responsibility? Easy. This is a combination. That means 25C5. So once you solve this one, 25 factorial, 20 factorial into 5 factorial. How did I get it straight away? Because there is no order. Order doesn't matter here. Because they have the same responsibility. From these 25, 5 should be selected. That's it. Next one. Find the 5th term of the expression 2x minus 5 to the power 7. Binomial expression. Sorry, binomial expansion. So 2x minus 5 to the power 7. How do you find TR? It's NCR 2x to the power n minus r minus 5 to the power r. Okay. Now 5th term means r equals 5. So T5 means and n equals 7 here. So T5 is 7C5 2x to the power 7 minus 5 2 minus 5 times r is 5. Therefore 7 factorial, 5 factorial, 2 factorial. Here 4x squared. Here minus 5 to the power 5. If you simplify this one, like this. So once you solve this one, you can get an answer. And it should be negative. Okay. The next one, 17th one. A bakery offers 5 different types of pastries. If a customer wants to buy a total of 12 pastries, how many different combinations of pastries can the customer choose, allowing for repetitions of the same type? Okay. Oh, hold on. I have 16. In how many different ways can 12 people be seated around a circular table if 4 of them must sit together? Okay. This is circular permutation. Now there are 12 people. Okay. 12 people. And 4 of them should sit together. These 4 should sit together. We'll take these 4 people as 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 people around the table now. So circular permutation, the theory is n minus 1 factorial. If there are 9 people around, that means 8 factorial. But this is not the answer. You have to multiply it by 4 factorial. Why? Because these 4 people can interchange their places as well. Therefore, 8 factorial into 4 factorial. Okay. Next one. A bakery offers 5 different types of pastries. If a customer wants to buy 12 pastries, how many different combinations of pastries can the customer choose, allowing for repetitions of the same type? Okay. Um, Here the concept used is stars and bars. If you know the theory, the equation is n plus k minus 1 t k minus 1. Here n is what? N is total number of objects. K is number of types. Okay, this is the concept using stars and bars, but I prefer the equation. So I'm using the equation n plus k minus 1 c k minus 1. This is same as NCR, but instead of R, you substitute k minus 1. Okay. Now, total number of objects is here 12. Number of types 5. Then it should be 12 plus 5, 17, minus 1, 16, C, k minus 1, 4. 16, C, 4 is the answer. If you simplify this one further, 16 factorial over 12 factorial, 4 factorial. Remember the equation, okay? N plus k minus 1, C k minus 1. Okay. Next one. 18 question. This question I took it from the tutorial itself. Let's do this. Early in the century, the earthquake in San Francisco registered 8.3 on the Richter scale. So they have given an equation m equals log I over s to the base 10. Okay. Now here they say San Francisco registered 8.3 on the Richter scale. This is the Richter equation. So 8.3 equals log 10 I over s. Okay. And then they say another earthquake was recorded in South America that was 4 times stronger. That means it's intensity. So here I is intensity. Intensity was 4 times stronger. That means this is San Francisco in South America. It is log 10 4I over S. S is what intensity of standard earthquake. That is common. Okay. I'll take this one as P. Now once you simplify this one, what do you get? E equals log 10 4. Here I can write this 4I over S as 4 times I over S. So multiplication means an addition. So here log 10 I over S. This part we know the value 8.3. So P equals 8.3 plus log 4 to the base 10. This is the answer for the first term. Okay, no need to simplify. We don't know the value. Then they say a recent earthquake in San Francisco measured 7.1 on the Richter scale. How many times more intense was the San Francisco earthquake? Okay. This is the San Francisco earthquake 1. Okay. Therefore, 7.1 equals log 10 to the base. We'll take this one as I1 over S. Okay. Now, if we write this logarithm form in the index form, how can you write it? 10 to the power 7.1 equals I1 over S. I'll take this one as equation 1. And then other one was San Francisco 8.3 equals log 10 I over S. Okay. So if we write this in the logarithm index form, 10 to the power 8.3 equals I over S. Now what you can do is we can divide. 1 divided by 2. Then you get 10 to the power 7.1 over 10 to the power 8.3 equals I1 over I. So I1 is this much times intense than the previous one. Okay. I hope you got the answer. Next one. Negate each of the following statements. Okay. Now negate everything. Now we have all x, px, and sum of x, qi. Now negate everything means, now this is what we call universal quantifier. Now negation of universal quantifier is existential quantifier. That means like this. Negate of px is not px and turns to O. Existential quantifier turns to universal quantifier. and qy goes to negate of qy. That's how you negate everything. Next one, sum of x. That means all x. Px means negate of px. There's a O there. If there's an O, it should be an AND. And then for all y, here this is y, here also y. If there's all y, then you have to write sum of y is not qy. This is how you negate everything. Okay. Next one are easy. You have to study the what you call the logical equations. Then you can solve them. Those are not really hard. You can do it alone. Okay, I'll end it here. Any questions you want to ask? Any questions before the paper? If you're asking me how the paper's gonna be, I feel like it's gonna be an easy one. No, I'm not sure, but I'm predicting it's an easy. It should be an easy one. Any questions, y'all? Anything you need to clarify? Anything you need to ask? Anything I has done wrong here? No, no. Okay then. Okay, I hope you guys do well. Good luck. Thank you. Bye bye.
Thank you, Sonali.
ඉසුන් දන්නේ නැගිට්ටේ.
නෑ නෑ මං හිටිය.
මොර කියන්නවා.
හරි. මම පේපර් එක කරලා නෑ මම කරලා ආයෙ බලන්න. Bye.
අවුලක් නෑනේ.
අවුලක් නෑ හොඳයි හොඳයි.
Thank you.
Okay. Alright. Bye.
Bye.